In this video we're going to review using Similarity to calculate unknown lengths and shapes that are mathematically similar. I'll start off with a triangle and draw a horizontal line. Measurements of various lengths are added and the challenge is going to be to calculate the length marked h. If you remember, our process for this was to split the shape up into two similar shapes, triangles in this case. Mark on relevant lengths, determine the scale factor, linking the shapes and use to find unknown lengths as required. The question is, why are they similar? If you remember, the process for this was, if all the angles are the same in both triangles, then they'll be mathematically similar, and we can justify these as being the same because there are corresponding angles and the angle at the top at the apex is the same in both cases. Anyway, we draw the diagrams and we mark on relevant information. Notice the height of the second triangle, we're calling that as h plus 8. We identify pairs of corresponding sides and we use that to determine the scale factor. So the scale factor of enlargement in this case is the big length divided by the small length, so it's 3, 15 divided by 5. So in other words, the small triangle times by 3 gives the big triangle. Now if you match up the corresponding sides for h, so h times 3 must be h plus 8. Therefore, h times 3 is 3h, that equals h plus 8. Solving this linear equation here, subtract h from both sides, divide by 2, we find h to be 4, and then by adding on 8 to it, we find h plus 8 is 12. So, another example. This time you could challenge yourself. You could stop the video and try to find the value of h. As before, we've got a triangle and we've got various lengths being given to us in the question. So stop the video, see whether you can do it. A bit more challenging this one because it involves fractions. Now as before, we split this triangle into two separate triangles, a big one and a small one. And mark on any of the relevant lengths. So this time I've actually got the length of the whole of the base rather than half the base. Identify pairs of corresponding sides, and from that deduce what the scale factor is going to be. So taking the green ones, the big one divided by the small one, 8 over 6, which is 4/3. And it's much more effective if we leave that as a fraction rather than going to 1.333, which should be a nightmare on a calculator. Now using the rules of similarity, we know that h times 4/3 is equal to h plus 4 because they're corresponding sides. So 4/3 of h is equals h plus 4. Now the trick here is to multiply through by 3 first of all to make it a bit easier for ourselves. It gets rid of the fraction. So 4h equals 3 lots of h plus 4. Expand the brackets. Subtract 3h from both sides and very easily we find h is equal to 12. And then obviously we can find what h plus 4 is going to equal, which is 16. And our units were centimetres.